and welcome back to our chemistry discussion. So this is the second video on chemistry, and in this video we will learn about chemical composition of water and thermal properties of water. Okay, so a single water molecule is shown here. It's composed of one atom of oxygen, which is represented in red here, and two atoms of hydrogen, which are represented in blue here. Okay, so water is composed of two hydrogen atoms bonded to one oxygen atom. So we write that as H2O. The 2 next to the H means that there are two atoms of hydrogen, and there's no number next to the right of the O, which means that there's one atom of oxygen. Okay, now, as I said previously, the oxygen and the hydrogen atoms are bonded together by sharing electrons. And if you would remember from the previous video, we learned that hydrogen has one proton, its atomic number is 1, which means that it has one electron as well. So it's sharing its one electron, and each of these hydrogen atoms are sharing their one electron with the oxygen atom. The oxygen atom has 8 protons and it has 8 electrons. So it is sharing 2 of those 8 electrons with the 2 hydrogen atoms. And if you would recall from the previous video, we learned that the type of bond that is represented when you have 2 atoms sharing electrons is called a covalent bond. Okay, so the covalent bonds hold the oxygen and the hydrogen atoms together. Now, I also started to discuss the fact that the hydrogen is much smaller than the oxygen atom. So what actually happens is that because the hydrogen only has one electron, its electron is already being pulled over towards the oxygen. And instead, what happens is on this end of the molecule, we end up with a positive charge because the electrons that are in the hydrogen are being pulled towards the oxygen. Then the oxygen has 6 remaining electrons that are not being shared. And therefore, what happens is the side that has the oxygen sticking out is negatively charged. Okay, so for a single water molecule, we have one side of the water molecule being negatively charged and the other side being positively charged. Okay, so we have a negative side and a positive side. And in molecules that have this, we call them dipolar, or you can just refer to that as polar. Basically, water has a bent structure, right? The hydrogen atoms are not attached to the oxygen atom in a straight line. Instead, they're attached towards one end. They're both attached on the same end, towards the bottom of the oxygen atom. So this gives the water molecule sort of a bent structure rather than being in a straight line. That bent structure then results in a negative charge on one side of the molecule and a positive charge on the other side of the molecule. And again, what we call that is polar or dipolar, di meaning 2 ends. So that is a little bit more specific than just saying polar. Okay, so this is a single water molecule. A single water molecule is made up of 2 hydrogen atoms bonded to an oxygen atom by way of covalent bonds. But what about when you have multiple water molecules held together? When you have, so here we have a water molecule, right here we've got the oxygen and then the hydrogens attached to it. And then notice that we've got another water molecule here attached to that water molecule, another one over here attached to that molecule, and etc. So we've got multiple water molecules that are attached together. Now the bond that holds those together is called the hydrogen bond. Okay, so a single water molecule is held to adjacent water molecules by way of hydrogen bonds. Okay. Now, water occurs on Earth in all 3 states of matter. We see it in the solid form, as in ice and glaciers and in polar ice caps. We see it in the liquid form in oceans and rivers and lakes. and precipitation, rain. And we also see it in the gas form as water vapor in the atmosphere. So what is it that changes the state or the form that water is found in? Well, water's state depends on heat. Okay, heat is defined as energy transferred from one body to another due to a temperature difference. So here we've got a pot of water that is over a fire, right? The fire is what is generating the heat. Then that pot then gets warm, and that transfers that heat to the water that's inside, or the stew, or whatever is in this pot, to increase the temperature. Temperature is actually a measure of the speed of the particles inside of it. So heat is actually produced by vibrations of atoms or molecules. With the hotter something is, the molecules would be moving more rapidly. And that's also called kinetic energy. So that's another example. Now, with water and other substances, as you change the heat, you eventually get to a point where the state changes. So solid, liquid, gas, those are examples of states. Okay, so when you have water in the solid form, which we refer to as ice, the water molecules are basically all bonded together. When we have water in the liquid form, that would be more heat. There would be a higher temperature than compared to the solid form. And here we have water molecules that are able to bond to one another and then also release from one another. And then with more heat, we get to the gas form, which is where all of the water molecules are free. They are not bonded to each other at all. So let's talk about that in a little bit more detail. Okay, over on the left here, we have in this box what water molecules in the solid state look like. So as you can see, right, the red is representing the oxygen, and the little blue circles are representing the hydrogen. Okay, so we've got a water molecule here. We've got the oxygen part of a water molecule up here, and you can keep on going, and you can see that all of the water molecules are bonded to one another. So that would be water in the solid form. That has the maximum number of hydrogen bonds. Okay, and when does that occur? At what temperature? That occurs at 0 degrees Celsius and lower than 0 degrees Celsius. So once the water gets to 0 degrees Celsius, it will freeze. And if it gets to colder than that, it's still just a solid. Okay, but if we were to add heat to this, then we would increase the temperature above 0 degrees Celsius. So you could say that 0 degrees Celsius is the freezing point, but you could also say that it's the melting point. Okay, so as the ice melts into a liquid state, what happens is those water molecules are no longer all attached to each other. Some of them are attached, but some of them are free, and they can basically bounce around and attach to water molecules more freely. Okay, so that term freely is a good example of what it looks like, what the water looks like, right? If you take water in the solid form and ice and you put it into your glass, that ice doesn't take on the shape of your glass. It's still that solid shape, right? But if you pour water into your glass, if you pour liquid water into your glass, that liquid water can freely form into the shape of the glass, okay? And again, that will happen at 0 degrees Celsius or above 0 degrees Celsius, okay? So that's why I said 0 degrees Celsius you can call the freezing point, right? If you're basically removing heat, getting colder, going to 0 degrees Celsius is going to start freezing. But if you have really cold ice and you start raising the temperature up to 0 degrees Celsius, then you're going to start seeing it start to melt, okay? Now, let's go back to our liquid water here. So now our liquid water is, we've got freely moving water molecules, but they're also bonding to each other. If we continue to increase the heat to 100 degrees Celsius temperature, then what's going to happen is you have water, the liquid form, boiling. And what boiling is actually doing is breaking the hydrogen bonds that are attaching adjacent water molecules together and releasing free water molecules. So when water is in the gas state or form, that means that there are no hydrogen bonds in between water molecules. Those water molecules are just moving freely. Okay, so let's look at in a little more detail about what happens when you take ice and you put heat into that ice and form a liquid and continue to put heat into it, okay? Okay, so what we're going to look at here is what happens when we take 1 gram of ice that is at negative 40 degrees Celsius and add 20 calories of heat. Okay, so on the x-axis we have calories, so you can think of that as energy being added to the ice. And on the y-axis we have temperature in degrees Celsius. So again, that is a measure of how quickly the molecules are vibrating or moving. Okay, so our y-axis starts at negative 40. That is our beginning temperature of our 1 gram of ice. Okay, so if we add 20 calories to this ice, what happens is it raises the temperature from negative 40 degrees Celsius to 0 degrees Celsius. Okay, and that's labeled as A. Okay, so what does the water look like from negative 40 to 0? You should have said that you have all of the water molecules attached together, and that forms sort of a crystalline structure, basically where all of the water molecules are bonded together. Okay, so let's go back to our graph again. So now we're here at this point that's labeled A on the graph. We've added 20 calories to raise the temperature of the ice from negative 40 degrees Celsius to 0 degrees Celsius. Now, if we add an additional 80 calories to this 1 gram of ice, we get from the point labeled A to the point labeled B. Notice that at A and at B, the temperature is the same. The temperature remains at 0 degrees Celsius, but we added 80 calories of energy. So why did our temperature not change? Well, what was actually happening from A to B is that the hydrogen bonds that were making it so that all of the water molecules in the ice form or in the solid form are all bonded together, the energy that was being added, that 80 calories, was actually breaking those bonds and changing the state from a solid which is at point A, to a liquid, which is at point B. So at point B now, all of the original 1 gram of ice is now liquid water. Okay, so again, liquid water means that you've got the molecules moving more freely. They bond to each other, but they also move more freely. They can attach and reattach, and they have a more free-flowing form. Okay, so now we're at B here. If we add another 100 calories, so right, we go from 100 here to 200, that's 100 calories, we get from B to C. Okay, so we were at 0 degrees Celsius at B, and now at C we're at 100 degrees Celsius. Okay, so remember that temperature is a measure of how fast the molecules are moving. So we are seeing an increase in the molecular movement and the speed of the molecules between B and C. Once we get to C, we now have water at 100 degrees Celsius. And remember that that's the boiling point. So at C, our water starts to boil. We add another 540 calories of energy to this water. And notice that even though we added 540 calories, this line is staying flat. We don't see an increase in the temperature. The temperature is staying at 100 degrees Celsius from C to D. So what is that energy doing then if it's not changing the temperature? If you said that it's changing the state from a liquid to a gas, you would be correct. Okay, so at C, we have water as a liquid at 100 degrees Celsius, and at D, we have water as a gas at 100 degrees Celsius also. Okay, so what does water in the gas form look like? It looks like molecules that are not attached to each other. There are no hydrogen bonds here, and they are all moving completely freely. Okay, so that's what happens when you go from a solid to a liquid and from a liquid to a gas, right? It's a change in the energy that is being put into the system, right? And we could go back the other way. We could have a gas, we can cool it down so that the water molecules start bonding together and form a liquid, and we can continue to cool that down so that all of the water molecules bond together and form a solid, right? And when I say cooling down, basically that means removing heat. Okay, so I want you to take a minute to answer some questions, and you are going to need to post your answers to these questions in the Canvas weekly discussion. So number 1, in what state will water be if its temperature is negative 10 degrees Celsius? Number 2, in what state will water be if its temperature is 130 degrees Celsius? Number 3, what is happening to water at the molecular level when water is boiling? And number 4, which state has the most hydrogen bonds? So solid, liquid, or gas. Okay, again, answer all of these questions in your weekly discussion post. And in our next video, we're going to learn about water's physical properties.